Welcome to the second training video. This video provides a detailed run-through of how to use the TII carbon tool. Hopefully you have all watched part 1 of the training, which sets out the context and provides an overview of the tool's purpose and functionality. We will now run through a demonstration of how to use the carbon tool. Please note if you wish to gain access to the tool, email climatetools@tii.ie to request access. Upon opening the tool, users will be directed to the introduction page, which provides background detail on the tool, similar to the detail that is provided in the first training video. The sidebar menu on the left-hand side can be used to navigate through the tool, as it links the user to different tabs within it. We will now run through how to use the tool tab by tab, demonstrating where and how to include various pieces of information and other functionalities of the tool. For the purpose of this training, please note we have used mock data only. Before demonstrating how to start a new entry in the tool, I will show how data can be added, edited, and deleted in the tool. Data can be added in two ways. Firstly, by using the Add button. Once selected, a pop-up box will open where relevant information and/or data can be inputted. Volumes and amounts must be entered by the user into the specific cells restricted to number format inputs only. Some fields are drop-down menus for selecting predefined options. Once selected, the unit field will automatically populate based on this selection. Assumptions, notes, and other comments should be entered in the field's comments. Alternatively, users can use the template download and upload function. Once the download template button has been selected, a clean file will be downloaded to the user's desktop, which can be populated outside of the tool. Note, if there is existing data in the tab that users are adding data to, it will not be included in the downloaded template. Once populated, users can upload the file back into the tool by selecting the Upload from Template button and then selecting the relevant file. The data should then appear in the table of the relevant tab. Users can use both ways interchangeably, noting that either method will append to the existing data in the table rather than replace them. Therefore, be mindful of duplicate rows. Data can also be edited throughout the tool. To modify an existing entry, select the relevant row. This will then highlight blue. Click the Edit button and a pop-up window will appear, allowing the user to update the relevant fields for the selected row. After the changes have been made, click Confirm to return to the main table. Please note that data entries can only be modified one row at a time. To delete data, users can select as many rows as they wish to delete, followed by the Delete button. To load a previously saved file, select Load Data, and then select the file you wish to import, then select Open. Now I'll move on to demonstrate how to begin a new entry, starting with the Project Details tab. The purpose of the Project Details tab is to collect the details of the project for completeness and future reference, noting that some of this data is to be used in the outputs, so this section should be completed as accurately as possible. When you enter the project details on this tab, include information such as project reference number, name and value, as well as its phase and timeline. There is also a free text entry box where the user can enter a project description. The Scoping tab is where the user defines the scope and boundaries of the greenhouse gas assessment, including the number of road, light rail, and/or greenway options to be assessed. As mentioned in the first training video, the tool allows for between 0 to 8 options to be inputted. Users should use the drop-down boxes to select the number of road, greenway, or light rail options to be assessed. This will create a separate tab in the left-hand side menu to enter project activity data for each of the options. For example, when the number of road options is 2, Two separate tabs will be created, Road Option 1 and Road Option 2. The user can scope in and out different data points under the different project stages listed in this tab, including pre-construction, product, construction process, operation and use, and lastly decommissioning stage. As an example, under pre-construction, based on data availability and relevancy, the user can scope in or out clearance and demolition activities, land use change and vegetation loss, and water use during clearance and demolition activities too, and so on and so forth for the other project stages. Where activities are scoped out, a justification as to why must be included in the rationale section. It should be noted at this point that each of the tabs throughout the tool have guidance notes, which can be toggled on and off as the user likes. Once scoping has been completed, users should then use the sidebar menu to navigate to either the Road Home, Greenway Home, or Light Rail Home to proceed to the relevant data entry tabs depending on the project's type. This is the Road Home tab. It provides a dashboard of results broken down by scheme option and lifecycle stage. Whilst the Carbon tool can be used across TII's project phases, it is recommended a new version of the tool should be completed for each project phase. The previous data page in this tab allows the user to input or copy data from a previously completed version of the tool into this table for comparison purposes. If this is the first time that the tool is being used for this particular project, this table should be left blank. The high-level design page allows the user to collate and input information on the design of the infrastructure, including the length of the route, the number and length of bridges, tunnels, and a number of interchanges, again for comparison purposes. Note that the user should always complete the names column, as the text entered here for each option will be used throughout the tool on each of the option pages. It will be displayed in the top ribbon underneath the option number for ease of identification. For this video, please note that two road options have been selected for comparison purposes. I'll now demonstrate how to input data into the Road Option 1 tab. Under Road Option 1, in the left-hand side bar menu, there are a number of sub-tabs under which data associated with different stages of the project can be input. We'll now go through these one by one. The first is baseline data, which represents the existing conditions. Here the user can input information on scheme type, including whether it is a new project or upgrade or even a combination of both, the current estimated annual average daily traffic, AADT, for the dune minimum scenario, which is a scenario without the proposed project, as well as an estimated percentage of how likely this is to increase or decrease as a result of the proposed project. The following stage is pre-construction. This considers activities that will take place at the pre-construction stage of a project, which includes clearance and demolition activities, land use change and vegetation loss, and water use during clearance and demolition activities too. As we scope this out in the Scoping tab, note that I'm leaving this table blank. Within this pre-construction tab, as with other tabs, it allows the user to input carbon saving opportunities here, both proposed and implemented. It should be noted that inputting these carbon saving opportunities here is that for the purpose of recording and tracking initiatives and will not impact the calculations. Further information on the inputs are provided in the guidance notes, which, as mentioned earlier, can be toggled on and off as the user likes. Now moving on to the Embodied Carbon tab. This considers the product stage, including materials that will be used during the construction process, their lifetime to determine replacement cycles, and details of material transportation. Overall, the data entered here is used to calculate the outputs and is collated to give the embodied carbon for materials used in the construction of the project. In terms of the inputs required on the raw materials embodied page, when using the manual form to enter data, users should select the category, subcategory, and type of materials used during the construction of the project using the drop-downs. Users should also enter the quantity. A standard industry emission factor will be applied to the selected material from the Embedded Emission Factors database. These inputs then inform the embodied CO2 calculated by the tool. The tool also provides two options for accounting for maintenance material impact. Users can either enter a custom factor by ticking the box here, or if a custom factor is not available or known, by using the tool's default automatic calculation. Where users select a material associated with high usage and/or a high emission factor, a warning message will be displayed, flagging this, as you can see here, prompting the user to review lower impact alternatives. These alternatives can be explored by navigating to the Material Groups comparison page. Here, the user can select two material groups for comparison on the left and right-hand side of the page if the user would like. However, for this example, we can just use the left-hand side to select the specific material to be reviewed. The tool will then automatically populate a table displaying the emission factors for each selected material. Users can review this information and, where appropriate, substitute the flagged high impact material for the lower impact alternative on the raw materials embodied carbon page, like so. Such changes should only be made in the tool after they have been integrated into the design and their use of the project has been approved. This function is useful for highlighting where carbon savings can be made, but project-specific checks need to be made to ensure that the alternative materials are appropriate for use in practice. Note also that design modifications can deliver significant carbon savings and should be evaluated during project design too. Additionally, users have the option to enter a bespoke factor by clicking on the Add New Material page. The user must select the category and subcategory of material to be added, followed by the other boxes displayed on screen. Once added, the user must select the Add Material button to submit entry before returning to the Raw Materials Embodied Carbon page. Where users are using new materials in assessment, TII should be notified. If you have a large amount of data to upload, the template upload function is particularly useful for the completion of the embodied carbon raw materials page. It is less onerous than the manual completion. Use the template download and upload buttons here and here to do this, as covered at the start of the video. For transport of material, the mode of transport and estimated kilometres travelled for each material is required. This will therefore likely require the user to undertake calculations prior to inputting data into the tool. For example, using the quantity of materials to estimate the number and types of vehicles required, and having an understanding of material source locations to calculate total travel distance required. As previously mentioned, similar to the pre-construction tab, the Embodied Carbon tab also allows the user to record carbon saving opportunities. Following the Embodied Carbon tab is Construction. This considers construction activities that will take place during infrastructure development, including excavation activities, energy use of construction activities, water use, construction worker travel, and carbon saving opportunities. Data inputs required include details on the excavation activities needed. Under the construction activities page, the fuel or energy use for each site activity undertaken, the water use during construction on a separate page also, and details of construction worker travel to site. As with the transport associated with materials, prior calculations may need to be undertaken by the user before input into this page. The construction waste page is also designed to capture and account for waste materials that are taken away from the site to be disposed, reused, or recycled elsewhere. If the required information is not available, the construction costs should be provided, which will be used to estimate emissions arising from the construction waste using industry benchmark figures. To open the cost estimate table, click the button here. Again, both considered as well as implemented carbon saving opportunities can also be captured in this page. Moving on to the Operational Use tab. This calculates emissions associated with the operation of the infrastructure scheme, such as energy, water, and waste. This tab has several pages for data inputs, including operational energy use. Here, users should select the energy use category, choosing from lighting, signs, office facilities, etc. And for each, selecting the energy type as well as the anticipated annual energy consumption during operation. Operational water use. This requires input of anticipated annual water consumption in accordance with the units provided in the units column of the table. Operational waste. This requires the user to select the waste use category, subcategory, and route. An input of annual waste production, again in accordance with the units provided in the units column of the table. An input of waste transportation mode and distance in kilometres per year. Landscaping and vegetation. This requires details of landscaping and planting associated with the development, including vegetation type and associated area. This tab also allows users to capture carbon saving opportunities. Next is the Road User Emissions tab. This tab calculates emissions associated with the use of the road by the users. The data used in this tab would be taken directly from the outputs of the REM model. You may notice here there is no Add button. Data can be entered by either using the download/upload function or modifying the row. Users can also include carbon saving opportunities here too. Moving on to the Maintenance tab. This calculates emissions associated with the fuel used for the maintenance of the infrastructure scheme during its use. Note that the embodied carbon associated with maintenance was already covered in the Embodied Carbon tab, as previously discussed. The data required for this is fuel use for maintenance plant per year. And like other tabs, carbon saving opportunities can be captured here. Lastly is the End of Life tab, which considers the decommissioning of the scheme, including deconstruction and demolition activities as well as waste disposal. Under deconstruction activities, the user selects activity type, fuel type, and inputs fuel use per hour as well as operating hours. Decommissioning waste, the user selects waste categories and routes and inputs the quantities of waste as well as the mode and distance of transport. Carbon saving opportunities can also be captured. We have now run through all tabs that fall under Road Option 1. In this example, we included 2 road options for the sake of demonstration. And as you can see, Road Option 2 has the same tabs available to fill in, which are to be populated in the same way as Road Option 1. After the user has finished populating the option tabs, the Road User tab allows the user to view the data in different ways. For the purpose of this tutorial, I have added data to the tabs within Road Option 2 to demonstrate how options can be reviewed. Please note that data is mock data for exemplary purposes only. Data can first be viewed by emission breakdown by life cycle stage, showing Road Option 1 and 2, where you can toggle on and off the column graphs. You can also view by breakdown specifically on embodied carbon emissions. An even more detailed breakdown goes into further detail on data input. An emissions intensity page allows the user to view emission intensity per euro spent, which is dependent on details provided in the Project Details tab. Carbon saving options can also be viewed here. And data can also be viewed in pie chart form. That is the end of the road part of the tool. The next section is for light rail projects. This project example does not have any data populated for a light rail project. However, if one were to revise the scoping and select one light rail option, the same tab options for the entry of data would appear as in the road section of the tool. The minor differences between the road and light rail options are: firstly, under the embodied carbon section, there is an additional category for rail track to account for the different materials sometimes used in the construction of light rail projects. There is also a section for rail user emissions, which calculates the emissions associated with the change in road use caused by the option of the light rail scheme. As with the road user emissions, this data would be taken from the REM model outputs. It should be noted that the light rail section of the tool does not include or calculate the carbon associated with the construction or operation of the rolling stock or light rail carriages themselves, which are considered outside of the scope of this assessment. Moving on to the light rail summary, this tab is very similar to the road summary, with the tool allowing the user to view the data in different ways as previously demonstrated. Note that the tool does not allow for the road summary, light rail summary, or greenway summary graphs to be viewed simultaneously. The next section is for greenway projects. Similar to light rail, there are minimal differences in the tabs and data entry inputs required here compared to the demonstrated road project example. The Greenway Summary tab also provides the same functionality as the other summary tabs too. Once the user has input all of their data, the Save button at the top right-hand side of the page should be used to save the file. Every time the Save button is selected, the file will be downloaded to the user's computer. Note that data is not stored on the tool itself, so the user must ensure to save data regularly to ensure work is not lost. In terms of providing background on the emission factors used in the tool, please refer to this tab. Whilst these can be seen throughout the tool upon the selection of specific materials, the larger library or database of emission factors that sit in the tool can be found here. The emission factors are sorted by categories or can be searched for in the search bar if the user wants to integrate them further. These factors are drawn from the latest publicly available datasets. Finally, at the bottom of the sidebar menu, there is a TII carbon tool guideline that can be downloaded, which provides background information and step-by-step instructions in case the user has any further questions. Thank you very much for listening.